And our next question is, if the function f of x defined by f of x is equal to log of 1 plus ax minus log of 1 minus bx upon x, if x is not equal to 0 and f of x is equal to k, if x is equal to 0, is continuous at x equal to 0, then find the value of k. Now we are given that the function f of x is continuous at x equal to 0, and which means its limit at the point x equal to 0 is equal to the value of at the point x equal to 0, or in other words, limit x approaches 0, f of x is equal to f of 0. And when x is not equal to 0, when x approaches 0, that means it is closer to 0. And if x is not equal to 0, then f of x is equal to log of 1 plus ax minus log of 1 minus bx upon x. And f of 0 is equal to k. So now this equation can be also written as limit x approaches 0, log of 1 plus ax minus log of 1 minus bx upon x is equal to k. Or we can also write it as limit x approaches 0, log of 1 plus ax upon x minus log of 1 minus bx upon x equal to k. Because as per the properties of limits, you know it very well that the limit of difference of two functions is equal to the difference of their individual limits. So we can also write this equation as limit x approaches 0, log of 1 plus ax upon x minus limit x approaches 0, log of 1 minus bx upon x equal to k. And now from the properties of limits, you know it very well that limit x approaches 0, log of 1 plus x upon x is equal to 1. But here we are given log of 1 plus ax upon x. So now if we can write this equation in the form of log of 1 plus ax upon ax, then it will be quite easy for us to find the limit of this function. So for that, what we do, we multiply the numerator and denominator by a in the first part, and in the second part we multiply the numerator and denominator by minus p. So now this equation becomes a into limit x approaches 0, logarithm of 1 plus ax upon ax minus p limit x approaches 0, log of 1 minus bx upon minus b into x is equal to k. Now you can see in the first part we multiplied the denominator by a and also multiplied the numerator by a. In the second part we have multiplied both numerator and denominator by minus p. And now from the definition of limits, limit x approaches 0, log of 1 plus ax upon ax is equal to 1, and also limit x approaches 0, log of 1 minus bx upon minus bx is equal to 1. So now this equation becomes a into 1 minus b into 1 is equal to k, or a plus b is equal to k. So that means the value of k for which the given function f of x is continuous at the point x equal to 0 is k equal to a plus b. And our next question is, find the values of a so that the function f of x defined by f of x is equal to sine square ax upon x square if x is not equal to 0 and f of x is equal to 1, where x is equal to 0 is a continuous function at the point x equal to 0. Now again, from the definition of continuous function, we know it very well that a function is continuous at a point if and only the value of the function at that point is equal to the limit of the function at that point. So in this case, the function f of x will be continuous at the point x equal to 0 if and only limit x approaches 0, f of x is equal to the value of the function at the point 0 or f of 0. Or in other words, limit x approaches 0, sine square ax upon x square is equal to the value of the function at x equal to 0, and as per the definition of this function, the value of the function f of x at x equal to 0 is equal to 1. So that means f of 0 is equal to 1. Now this limit can be evaluated if we can write sine square ax upon x square into some simpler form in which the limit can be calculated easily. Or in other words, if we multiply numerator and the denominator by a square, then our equation will be a square into limit x approaches 0 sine square ax upon a square x square is equal to 1, and which can be also written as a square into limit x approaches 0 sine ax upon ax whole squared is equal to 1, and limit x approaches 0 sine ax upon ax is equal to 1. Now as per the properties of limits, limit x approaches 0 sine ax upon ax is equal to 1. So this equation simplifies to a square into 1 square is equal to 1, or a square is equal to 1, which means a is equal to plus minus 1, and which means the given function f of x given by sine square ax upon x square when x is not equal to 0 and f of x equal to 1 when x is equal to 0 is a continuous function at x equal to 0 if a is equal to 1 or minus 1.